Hello, welcome. Today let's try to solve another Leetcode problem. 1462, course schedule number 4. Let's try to understand the question a little bit, and then I'm gonna analyze the problem in whiteboard. After that, I'll go back to the code editor to finish the coding. So let's just check the example. So for example, we have number of courses equal to 2. So the prerequisite is still the same, like course 1 or course schedule 2. So for example here, 1 is the prerequisite of 0. So it means 1 will be connected to 0. Yeah, this just means 1 is the prerequisite. Yeah, and now we also have a queries. We just need to answer the queries. For example, 0 to 1, it is not connected. So it's going to be false. And 1 to 0, it is connected. So it means this 1 is the prerequisite of 0. So it is true. Yeah. Now let me go to the whiteboard to explain my solution. After that, I go back to code it up. Now let's just check some later if we can use brute force or not. Yeah, so number of courses is 100 and the prerequisite length is like 10,000. It means 100 times 100 basically. And here is the prerequisite dot length is just 2. So it means this question can be solved by brute force. But I'm going to solve it. I'm not sure if it can pass for the brute force because brute force basically you're gonna use DFS and there are queries. It is 10 to the power of 4, and for each of the queries, if you are using the DFS, the answers will be 10 to the power of 4, so it will be 10 to the power of 8. Normally you cannot pass. So this is why I'm gonna use topological sort plus BFS to solve the problem. Let me analyze the problem a little bit from the whiteboard. After that, I'll go back to the code editor to finish the coding. I did some preparations. I made some drawings for this problem. Let me wait. It's gonna be a while, so I would prefer to I would prefer to code it up from here and then just go back to check if the whiteboard is available. So it means the whiteboard is not okay. Now let me go back to the code editor to finish the coding. I think the problem is the template of topological sort plus BFS. So we just need to prepare another variable. For example, we would we need to prepare a search table. This search table would be a 2D search table. So inside of the search table, we can search the queries if it is right or wrong, if it is true or false. Now let me do some preparations. After that, I will analyze it in whiteboard. So basically for the topological sort with BFS, we're gonna prepare a graph and integers. So for the graph, it will be a default dict, and inside it will be list, and the degree should be 0 times the number of courses. Because this is the integrity, we're gonna check the integers of each node, and then we're gonna use the BFS. Now let me do some preparations for the graph and integers. So normally we can look through the prerequisites. So for A and B in the prerequisites. So for the graph, the G. So this means A is the prerequisite of B. So GA should append this B to the graph. And for the integers, actually, it is integers B should plus equal to 1. Now, I just need to prepare a queue. So the queue should be the queue, and inside I'm gonna put the node with integer 0. I would put the node with the integer zeros inside this queue. So it should be I for IV in enumerate the integer if this value equals to 0. Yeah, but I also need to prepare a search table because I need to search the result from this search table. So the search table would be a 2D array. Inside from the beginning, it's gonna be always false times number of courses, and the rows of the search table should be the number of courses. It would be the number of courses. Yeah. So now we just need to check the queue. So the node should equal to the current node should be equal to q dot pop left. Yeah. Now let me check if the whiteboard is okay. Yeah. Let me put some drawings here. Let me make some. Yeah, let me first code it up from the code editor, and later on check if it is working. Yeah, so we need to pop out the node from the queue. So for example, here it would be the node 1. This node 1 will be popped out. Now I'm going to check the neighbors for the node. So for neighbor in J with this node, if yeah, so from here, so for the neighbor, for example, this neighbor is 2, so it means this node has already been connected with the neighbor. Yeah, so I'm going to update my search table. So the search table with node and neighbor would become yeah, search table with this node and neighbor would become true because it is connected. Yeah, so this means 1 is a prerequisite of 2. So for the search table, I also make it a 2. It means the node is prerequisite of this neighbor. Yeah. Now I'm going to check all the node inside the num of courses. So for I in rate num of courses. Yeah, so this is similar to Dijkstra's algorithm. Yeah, so this is a search table. So inside of the search table, we just need to check the node. So this currently, so for example, 1 has already been connected to 2. So we just need to check all other nodes if it is connected to 2. So how should we check? So if it connected to 1, it must be connected to 2. So for example, if this 0 has already been connected to 1, and 1 has already been connected to 2, that means 0 is connected to 2. Yeah. So I'm going to loop through all the nodes. Yeah. So now I can update the search table. So for the search table, I with the node. Yeah. So for search table I with the node. So it means if this I would like to search all other node to search for example 0 if it is connected to it's not to the node, 0 connected to the neighbor. Yeah. So I would to check all other node, for example, because 1 connected to 2, I would to check if 0 has been connected to 2. Yeah, to check if it is connected with this neighbor. So how can I check? So I need to check if this 0 is connected to 1. Yeah, if it is connected to 1, it means it has already been connected to 2. Or this 0 and 2 has already been connected. So it would be, I need to use a OR to check. So it would be OR with the search table. With so here is with I neighbor, and here is a node with neighbor. So here should be node to neighbor. This is a node to neighbor, and here should be I to node because I'm going to check the I to neighbor. So I to node, not to neighbor. This is not to neighbor. So here should be this I to my current node. Yeah. After that, I gonna update the in-degrees. So for the in-degrees neighbor should be -1, and this is basically the template for the topological sort using BFS. So I need to check if this neighbor equal to 0. So if it is 0, I need to put it inside my queue. So the queue dot append with this neighbor. Yeah, and basically this is the entire code. Now I just need to return with the search table. Search table with I and I did many arrays inside. Yeah, basically inside it is just a search table. So the search table should be with I and J for I, J inquiries. Yeah, so this is basically the entire code. And from here, this is basically the template. And here also the same. The only difference is we added a search table. So the search table, and here we also added 2 lines of code to update the search table for each of the BFS. So for example, for 1 to 2, it has already been connected. Then only for 1 to 2, others I didn't traverse my BFS. I need to check if other node, for example, 0 connected to 2, or maybe there's a 3 connected to 2. So how should I check? Yeah, I need to check if this 0 is connected to 1. If this 0 is connected to 1, it means 0 is connected to 2. So for example here, this 0 connected to 2, is that true? It can be itself, or it can be the 0, this I to the node, I to 1, 1 to 2. Yeah. Now let me go back to check if the whiteboard is working or not. Yeah, so I'm not going to make a drawing here. So yeah, just analyze these 2 lines of code, why it always work. Yeah, so this is just a trick for the topological sort. While we are using BFS, we can check all other connections of the node. Yeah. So for example, 1 to 2 is connected, 2 to 0 is connected. Then if 1 to 0 is not connected, we just need to check if 1 to 0 is connected or not, because 1 to 2, 2 to 0, and then we can directly get the result 1 to 0 is connected, because currently 1 is so for example, currently if 2 is the current node and 0 is my neighbor, and I'm going to I'm going to check if this 1 is connected to 0. So I'm going to check 1 connected to 0, because 1 has already been connected to 2. So this means 1 must connect to 0. So this is the meaning of this line of code. Thank you for watching. Now let me analyze the time complexity a little bit. After that, I think that's all for this question. So we can check here. Basically, this third table, the time complexity for this third table is n squared. So n is the number of courses. It is 100. So it is just 10,000. And for here, this q is the number of courses. So it is just 200. And here, let's check the prerequisites. So how many prerequisites? Let's check the length of the prerequisites. It is also 10,000. It is also n squared. So up to here, it is still n squared. Now let's check the queue for BFS. So for this queue, how many nodes inside the queue? It is 100. And for here, for I in raised number of courses, it is also 100. So here is also n squared. So finally, the time complexity is n squared. If you need to calculate others, maybe n squared plus n squared plus n. Because this queue, this is n, and here this is n squared. 3 times n squared plus n. So finally, it will be n squared. Thank you for watching. See you next time.